Okay, welcome to today's GCSE revision. We're going to look at trigonometry questions and questions about vectors today. A couple of quite difficult subjects. Don't be put off. Okay, here's a trigonometry question from June 2012. Work out the size of angle P. So the information that we've got is 15 centimeters, which is the hypotenuse, and 9 centimeters, which is the adjacent, because it's the one that's next to the angle P that we're trying to find out. So if you remember your trig ratios, you remember that cos equals adjacent over hypotenuse. So that means that cos of angle P is adjacent over hypotenuse, 9 over 15. So we need to find out what P is. So P isn't the cos of 9 over 15, it's the value that when you do the cos of it gives you the answer 9 over 15. So in other words, P is the inverse cos, or arc cos is the word I like to use, of 9 over 15, which is 0.6 by the way. So the inverse cos of 0.6, and if you get your calculator on that, you find that that is 53.13 degrees. Okay, also from June 2012, this is an advanced trigonometry question. It's advanced because it uses the trigonometry rules that don't concern right angles. So these rules are on the formula sheet. In any triangle, ABC, any triangle, so it doesn't necessarily have to be right angled, the area of a triangle is a half AB sine C, and then you can find missing sides or angles depending on which sides or angles you're missing, using either the sine rule or the cosine rule. Now this general triangle it's talking about is labelled so that the angles are big A, big B and big C, and then the sides opposite them are little a, little b and little c. So the corresponding upper and lowercase letters are always opposite each other. Big B is the angle opposite side little c, little b, and so on. So back to this question. Let's just fill in some of the obvious information. We've got 39 degrees here, 43 degrees here. So this one must be 98 to make triangle BCD add up to 180. And similarly for triangle ABD, 33 added together with 57 and 90 makes that one add up to 180. Now this isn't drawn accurately, as you can see. This is clearly less than 90 degrees, so it can't be 98, but that's just to prevent you from getting an answer by measuring the diagram. Now I'm going to work out some missing sides using the sine rule, and that basically says that a side divided by the angle opposite it, or the sine of the angle opposite it, gives you the same result whichever side and angle you take. So for example, in this triangle here, AD divided by the sine of 33 should give you the same result as this side here, which is 9, divided by the sine of this angle here, which is 90. So AD over sine 33 equals 9 over sine 90. Well, most of that is stuff we can work out on the calculator. And that means that if we want to know what AD is, we need to multiply both sides by the bottom of that fraction, which is sine 33. So both sides multiplied by sine 33 give you AD equals 9 times sine 33 divided by sine 90, which is something you can work out on your calculator, and it's about 16.5. Similarly, in this triangle here, we've got the side CD, and whatever that is, when you divide it by the sine of the 39 that's opposite it, sine 39, you should get the same as when you divide this side, 9, by the angle that's opposite it, sine 98, so 9 over sine 98. So this side divided by the sine of this angle is the same as this side divided by the sine of this angle. That's the sine rule. In fact, I'll just write here that I've used the sine rule. And here. Okay, so if I multiply both sides of that by the bottom of that fraction, so that I just get CD on its own. So multiply both sides by the sine of 39. So side CD is 9 times the sine of 39 divided by the sine of 98. And if you work that out on your calculator, it's 5.7. Okay, so we just worked out that that's 5.7 centimeters, and previously we worked out that AD was 16.5 centimeters. So that's given us some extra information about the triangle that enables us to use this rule here for the area of a triangle. Now this says the area of a triangle equals a half AB sine C. So A and B here are small letters, so they're sides. A and B here you can see. And then sine C, so sine of angle C, that. So it's basically saying that the area of a triangle is a half times 2 of the sides times the sine of the angle between those two sides. So if I want the area of these two triangles, well, let's have a look at this one first. So I'm going to say the overall area is going to be the area of triangle ABD plus the area of triangle BCD. So I'm going to work out the overall area by working out the area of the two triangles and adding them up. And the formula we just looked at for area of a triangle says that you can find the area of a triangle by doing a half times 2 of the sides times the sine of the angle between them. So here, for example, in this triangle ABD, we know 2 of the sides are 16.5 and 9, and we know the angle between them is 57. So the area of that triangle is a half, or 0.5, times the two sides, 16.5 times 9, times the sine of the angle between them, the sine of 57. And then the other triangle, same thing. We know 2 of the sides are 9 and 5.7, and we know the angle between them is 43. So the area of that triangle is a half times two sides, 9 times 5.7, times the sine of the angle between them, sine of 43. So that's all stuff you can work out on your calculator, and it comes down to 62.3 plus 17.5, which is 79.8. You might disagree with the 0.8 depending on if you did it to more decimal places than me. But the working is the thing there that will give you most of the 7 marks for this. So a good clear working and show what you're doing. Okay, back to more familiar trigonometry with right-angled triangles for question 12 from November 2012. Now this one's a bit odd because it gives you all the sides and it says write down the value of sine x. So x is that angle there. So you just need to remember what sine means. Now sine equals opposite over hypotenuse. So sine of that angle there is the opposite divided by the hypotenuse. The hypotenuse is the longest one. The opposite is the one that's across from x, so that's the opposite. And then the adjacent is the one that's next to it that isn't the hypotenuse, so that's the 4. So sine of x is the opposite over the hypotenuse, 3 over 5, 3/5. Or you'd get the mark for 0.6, but don't ever write 2 answers for anything, because if you get 1 right, 1 wrong, then you can be marked down for the wrong one. In a different right-angled triangle, tan of 0.7, sorry, tan of y equals 0.7, work out the value of y. So, right-angled triangle, some angle y, and the opposite over the adjacent, because that's what tan is 0.7. So when you know what the tan of an angle is and you want to know what the angle itself is that gives 0.7, when you do tan to it, you need to use the inverse trig functions. So y is the arctan or inverse tan of 0.7. So let's just get the calculator on that. 0.7, then second function I have to press, tan, and it's just about 35 degrees. 35 degrees. So 35 degrees is the angle that when you do the tan of it gives you an answer of 0.7. In fact, let's just try that. 35 tan, just about 0.7. Okay, last trigonometry question for today. The man is 1.8 meters tall. Let's just put that in, 1.8. Work out the height of the building. So whatever the height of the building is, it's this 1.8 meters plus a missing side from the triangle. So I'm going to call that missing side x. And we're working with an angle of 35 degrees and a right-angled triangle. So what we've got is x, which is the opposite side, and 40, which is the adjacent side to the 35 degrees. So we need to think which trig ratio involves opposite and adjacent, and that's tan. So we can write down that tan of 35 degrees equals opposite over adjacent, x divided by 40. So x itself, we need to multiply both sides by 40 to get rid of that fraction. X itself must be 40 times tan of 35 degrees. And that's something I can work out on my calculator. So 35 tan is that, times 40 is, well, just about 28. So x is 28 meters. So the height of the building is x plus 1.8, because it's the missing side in the triangle plus the height of the man. So that's 28 plus 1.8, which is 29.8 meters. So the building is 29.8 meters high. Okay, on to questions about vectors. Now, vectors, remember, they are mathematical quantities that involve a specific length or magnitude and a specific direction. So, for example, from w to x is a vector, and it can be written as wx with an arrow over the top of it, or it can be labelled with a single letter, and it's called s here. So wx and s are the same thing. It's the movement of this distance in this direction. So it says write vector zy in terms of s. There's some key information here. Zy to wx is 3 to 2. So for every 3 of these, zy, there's only 2 in the same direction of wx. There's also some important information at the top that the whole thing is a trapezium, meaning that it's got 2 parallel sides. So wx and zy go in the same direction. So wx and zy are in the same direction, except zy is longer, and for every 2 of these wx, there's 3 of these, or the length is 3 of zy. So it says write vector zy in terms of s. Well, clearly it's 3 over 2 times bigger than s, so it's 3 over 2s, or if you like, 1.5 s. So it's like this one, it's in the same direction, except it's longer by a factor of 3 over 2, 1.5. Then it says work out vector xy, so that's the vector that takes you from x to y, so this one in other words, that movement, in terms of s and t. Now there's no direct way of getting from x to y in terms of s and t, so what we need to do is work out a way of getting from x to y that involves s's and t's. So for example, we could start at x, go backwards down s, so that's minus s, go along t, so that's plus t, and then go along zy, which, as we established in, let's just cross out these confusing 3 and 2, as we established in the previous part, is 1.5 s, so plus 1.5 s. So going from x to y is the same as going from x to w to z and ending up at y. So that's the same as going backwards on an s, along a t, and then along 1.5 s. Minus s plus t plus 1.5 s, and you can collect together the algebraic terms of that. So there's minus an s plus 1.5 s's makes 0.5 s, and then collect together the t's. There's only one of them anyway, so plus 1t, plus a t. So from x to y is 0.5 s plus t. Half of an s plus a t takes you from x to y. It won't look like it in the diagram because, as ever, it's not drawn accurately. So for example, on this diagram, the ratio between these two sides isn't actually 3 to 2. If you were to measure it, it's a lot different. So trust your algebra, even though the diagram might look a little bit wrong. Okay, next question on vectors is from the November 2012 paper, question 17. So let's look at the information we've got. AB equals 2x. So from A to B is a vector, AB, and it's the same as 2x. So 2x and AB both represent that movement in that direction of that distance. And BC equals 4y. So from B to C, vector BC is a movement in this direction and this distance, and that's also equivalent to something that they're calling 4y in the question. And it says, write down vector AC in terms of x and y. So to get from A to C, if we want to do it in x's and y's, we've got to go along here, which is 2x's, and then down here, which is 4y's. So it's 2x plus 4y, one easy mark. Part B, AC to CD equals 2 to 1. So if AC is 2 units, then CD is only 1 unit. So in other words, AC is twice as big as CD. So the 2 and the 1 altogether make 3. So in other words, C is 2/3 of the way along the line. So then it says, work out vector AD in terms of x and y. So from A to D, well, we already know what A to C is. We know that A to C is 2x plus 4y. We did that in the previous bit of the question. And from A to D is in the same direction, but just longer. How much longer? Well, it's longer by a factor of 3 over 2. So AD is 3 over 2 times as big as AC, which is 2x plus 4y that we worked out in the previous part of the question. I prefer decimals, so I'll change the 3 over 2 to 1.5. So it's 1.5 times 2x plus 4y in brackets. 1.5 times 2x is 3x, and 1.5 times 4y is 6y. So it's 3x plus 6y. So if you go along 3 x's and 6 y's, it will take you from A to D. Okay, so the last vectors question for today. The diagram shows vectors OA, from O to A, and that's also called small letter a, and OB, from O to B, also known as small letter b. Write vector AB in terms of A and B. So something that will take us from A to B in terms of little a's and little b's. We can't do it directly, but if we go from A to O, that's backwards down little a, so that's minus an a. And then from O to B, that's going along a little b, so minus a plus b, and that's it. If you go minus a plus b, backwards down an a and along a b, then it gets you from A to B. Now, that was the first part of the question, and it's simple enough. Second part is a little trickier. It says, the point B divides AC in the ratio 2 to 3. So there's the point B, and it says it divides AC in the ratio 2 to 3. So for every, so if A to B is 2 units of whatever, then B to C is longer, it's 3 units. So 2 and 3 make 5 in total, which means that B is 2/5 of the way along, 2 out of 5, 2/5 of the way along the line AC. So the question is, work out the vector OC in terms of A and B. So to get from O to C, how can we do it? Well, from O to C, we could go via B. So going from O to C is the same as going from O to B and then to C. So I'm going to write OC equals OB plus BC. Going from O to C is the same as going from O to B first and then from B to C. Going from O to B, well, that's also called little b. So O to B is the same as a little b. Now from B to C is a bit more complicated, but we know that it's in the same direction as from A to B, but for every 2 in distance of AB, there's 3 in distance of BC. So it's like doing an AB, but it's 3/2 times as big. So BC, from B to C, is 3/2 of the smaller AB. Now that's useful because in the previous part of the question, we worked out what vector AB was in terms of A's and B's. And vector AB was minus A plus B. So I'm going to replace the AB with its equivalent in little a's and b's, minus A plus B. So now we've got everything in terms of little a's and little b's. And we'd like to simplify that, so we're going to multiply out the brackets. So 3/2 times minus A is minus 3/2A. Or actually, I'm going to call that 1.5 rather than 3/2. So minus 1.5A. And then 3/2 times B is 3/2B, or 1.5B. So the whole thing is B plus minus makes minus 1.5A plus another 1.5B. Well, now we can gather together the like terms. So what have we got in A's? We've got minus 1.5A. What have we got in B's? We've got 1B here and 1.5B here. Makes 2.5 B's in total. So the vector OC is the same as minus 1.5A plus 2.5B, or in other words, it's the same as going backwards, same as starting at O, going backwards down A 1.5 times, and then along 2.5 B's. Now don't get in too much of a panic about vectors, because it's probably the hardest topic on there, along with circle theorems, and it's there to separate the A stars from the A's. So not being able to do vectors and circle theorems shouldn't stop you from passing, but nevertheless, you should try and do them if you can.